Okay, so for diffraction, there's just one little concept I quickly want to explain. So they say there in your textbook that the degree of diffraction is directly proportional to the wavelength and inversely proportional to the width of the slit. So in other words, what happens here is we have some barrier that causes a wave here to bend there. And because it bends there, here it undergoes interference. Okay. Now, interference in light, specifically, remember that light has a dual nature. It acts like a wave and it also acts like a particle. So with diffraction of light, we're looking at the wave nature of light. So according to this theory, what happens here is that the light bends, and because the light bends, it undergoes interference. And now if we put a screen there, what we'll see on the screen is, let's say we had purple light, we'll see a central light band with alternate dark bands where there's no light, and then a light color band again. A dark band where there's no light, light color band again. Okay, so that will be a pattern that we'll see on the screen. Now what this says is that degree of diffraction, how much this light bends over here. We're going to see how much it bends by the size of that central light band. So if it bent a lot, like in this blue, that light bend a lot, then we are going to see a longer central light band. But if it only bends a little, like in this purple, just a bit like that, then we're only going to see a short central light band like that. Okay, so if we compare that shorter central light band there with a longer blue light band, that's what we'll see on the diffraction pattern of one that bent more. Okay, so this one had more diffraction, it bent more, and the purple one had less diffraction, which means it bent less. Okay, so if we have a longer wavelength, then we're going to have more diffraction. Okay, now you have to remember that if we divide white light into its 7 colors, then we have this: red, orange, yellow, green, blue, indigo, violet, rooi, oranje, geel, groen, blauw, indigo, violet. Okay, those are the colors that white light consists of. So red has the highest wavelength, violet has the lowest wavelength. Okay, and according to this, the higher the wavelength, the higher the degree of diffraction. So if we have a red light and we look at its diffraction pattern, it will undergo more diffraction, so it will bend more, so it will give us a longer central light band. If we compare that to blue, blue, for example, which has a much lower wavelength, give us a lower degree of diffraction, which means the light bent less. So it would give us a shorter central light band. The width of the slit means this little aperture opening that the wave has to move through. So if it has a huge, big opening, then a certain wave that needs to travel through it doesn't really need to bend a lot to move through it. But if we have a very small aperture, then that same wave needs to now move through this small little space. So it's going to bend a lot in order to move through there. Okay, so if you understand that and you understand what you studied in this chapter, then you're ready to go with this.